Welcome to the Bentley Systems training course where you will learn how to design steel structures in STAAD Pro Connect Edition. In this video, we are going to be focusing on specifying your steel design commands and performing the design and reviewing the results. In STAAD Pro, you can specify several different types of commands to analyze and design steel structures. The command that we're going to be focusing on in this particular course is the check code command. This will instruct STAAD Pro to determine if the assigned member properties are adequate to carry the applied forces. In addition to that, we also provide a select and a group command. The select command instructs STAAD Pro to indicate the minimum weight cross-section that is sufficient to safely carry the applied forces, and the group command instructs STAAD Pro to assign a common section to a group of members during optimization. Both of these commands are fully covered in the Optimizing Steel Structures course. So for our sample model, we're going to be invoking the check code command. Now that the design parameters have been assigned to the model, the check code command can be used to determine if the members are adequate to carry the applied forces. If the check code command finds members that are inadequate, you will be responsible for finding a new set of members to replace the inadequate ones. We will now return to our sample model where we're going to specify the check code command and then perform the design. To specify your design command, you're going to return to your Steel Design dialog and click on your Commands button. Here you're going to find all of the different design commands that are available. For this exercise, we're going to select the check code command. We'll click the Add button and then click Close. Now the check code command needs to be manually assigned to the different members in your model for which you choose to perform a design on. For this model, we're going to select all of the AISC sections that we had previously assigned through the Properties area. To do that, we're going to select the check code option. We're going to go to the Geometry tab in the ribbon and then use our By Property Name option. We're going to hold down our Control key. We're going to select our W sections, our HSS tube, and our angle sections. We're going to finish this off by clicking Assign, and then we're going to confirm that process for yes. Now we do have some plates in this model, and we do have some steel rods in this model as well. Now for these particular member types or element types, we can perform an analysis on this member and get things like section forces in the post-processor. A steel design is not going to occur on these members since they were not assigned using the standard AISC database. Once you are done invoking your check code command, you're going to save your model, and now we're ready to perform our analysis. To perform the analysis in STAAD Pro Connect Edition, we're going to go to the Analysis and Design tab in the ribbon and click on the Run Analysis icon. This will perform the analysis and the design in one step. Once the design is complete, it's a good idea to go ahead and check to see if you have any errors or warnings. This is the type of information that will be available in the STAAD Analysis and Design dialog once the design is complete. Now the first step we're going to go to look at for some design results is our output file. So right within this dialog, we're going to select View Output File, and then we'll go ahead and click Done. Now, if you already got past that dialog, you can also find the output file. We have an icon available in the Utilities tab in the ribbon. Now, once you get to the output file, we're going to go over to the pane at the left-hand side, and we're going to find the results area. Now, every time you invoke a steel design command, you're going to get a link to that section in the output file, and we can just click on that to jump ahead. Now, this section will contain the results of the check code command. This command checked the strength of each member according to the code requirements of the AISC 36010 LRFD specification. You can see this first piece of information I have here. I have my section size that was assigned. I have my pass or fail, and I also have an interaction ratio listed here. If I want some additional information, I do have it available in this particular model because I invoke that track parameter. And I would get this information for every single member that was included in the check code command. Now, if you are looking for how many passing or failing members you have in your model, a good way to quickly navigate through the output file is to use your find tool. So if I invoke the find tool, I can say, for example, find the word fail. I'll go ahead and say find next, and it's going to go ahead and look for instances of that. And this might be a quick way to just navigate through the output file. Now, once you're done reviewing the output file, we're going to go ahead and close out of it. And now we'll go ahead and take a look at our results a little bit more graphically. So we're going to go to our post processor. Over in your workflow panel at the left-hand side of your screen, you'll find a link to the post processor. Within the results setup dialog, we're going to go ahead and review all of the selected load cases that are provided. And if we go to the results view options tab in this dialog, we can enable automatic scaling. This will go ahead and adjust your graphics on your screen, such as stress diagrams or deflection diagrams, to get them a little bit more able to read your results. Once we're done, we'll go ahead and click OK, and here we'll enter the post processor. Now, we have several different types of results that are available within the post processor, and those different types of results can be obtained by selecting the different tabs in your post-processing workflow page control area. Now, most of your diagrams on your screen are going to be according to the currently selected load case. To select a different load case, you can go ahead and just use your pull-down menu available in your Results tab in your ribbon. So you can see that the deflected shape has been updated for that. Now, we have information on your deflected shape of your structure. We can go adjacent to that and go to the reactions area. And again, we can select different load cases if we wanted to see different pieces of information. Now, whenever you're taking a look at a particular area, you're also going to notice that the right-hand side of your screen within your data area is going to be updated to include your detailed tables. So this will be numerical values for the different properties available. So here we can see for node number 1, we have each load case that was analyzed and the support reaction for each one. Now, for this exercise, we're going to go ahead and take a look at the beam results area. This is where we're going to be spending our time. So we're going to take a look at the beam results area, and we have several different types of beam results available. To control the information that's appearing on the right-hand side of the screen within those tables, we're going to go to this Layouts tool. This is available in the Results tab of the ribbon. So let's go ahead and click on the Layouts area, and we can review the different types of beam results that are available. We have our beam forces, beam stresses, the utilization ratio, and also graphs. And this will change what you see in your main display, and it'll also customize the tables to be more appropriate. For this exercise, let's go ahead and click on the utilization layout. This is basically your results for your steel design. What we're going to see is that the model is going to be color-coded on your screen, and the interaction ratios are listed. Now, by default, anything that is passing will appear in green, which means it has an interaction ratio less than 1.0. Anything that is in blue is a failing member, which means it has an interaction ratio between 1.0 and 1.5. And anything that is in red is an extreme failure, meaning that its interaction ratio is greater than 1.5. Now, if you would like to review more information on that and how the interaction ratios and the color coding works, you can go ahead and click in your label settings area. So to do that, to find that information, we're going to go to the View tab in the ribbon and select our label settings. From there, we're going to go to our Design Results tab, and this is the interaction ratios that controls the color coding. Now, in addition to reviewing this information graphically on your screen, you can also use some other tools. For example, we have a Select Failed Members tool. This might be an easy way for you to go ahead and identify which members are passing and failing. Again, anything that's color-coded in red or blue will be selected with that option. So let's go ahead and try that. We're going to go ahead and select the Results tab in the ribbon. We'll select the By Property Name command, and then we can select all failed beams. In addition to selecting failing members on your screen, if we look over in the data area, we also have a tab to review any of the failing members in your model. And this will give you a good idea of which types of sections were failing during your initial design approach. Let's return now to the All area, and we're going to go ahead and take a look at the design results. Available in the design results table is your analysis and design properties, which for a code check, both these properties will be the same. This is the initial section size that you assigned. In addition to that, we're also going to be able to see our interaction ratio and the clause within the code for which caused the failure. Now we're going to notice that there are several beam and column members that are currently failing. What we're going to want to do is return to the modeling mode and assign new sizes to the failing members. After any sizes change, the model must be reanalyzed to verify if the new sizes pass the code check. And you're going to want to keep doing this process through a trial and error process until you achieve a passing design. Let's go ahead and take a look at that. To return to the modeling mode, we're going to go over to the Workflow panel and select the Analytical Modeling option. Once we're here, we're going to go to your Workflow Page Control area and select the Properties tab. And here we can see all of the properties that were assigned. We'll go ahead and start with the columns. These were originally assigned as HSS 6x6 by 3/8 members. To change the section property, you can do it on an individual basis, or if you want to change all of them, we can just update this section with a new section size from the database. To do that, we'll just double-click on this section, and then we can select another HSS tube. For this exercise, I'm going to select a 10 by 10 by 5/8. Once we're done, we'll go ahead and just click the Change button, and we'll click Yes. So basically, STAAD Pro has deleted your post-processing results because now your model has changed. We'll go ahead and click the Close button. In addition to that, we're going to select our beam members, and we're going to update these as well. We'll just double-click on this, and then we can select a new wide flange section from the American Steel table. Here we're going to select a W16 by 40. Click the Change button and then click Close. Now at this point, we've already changed the model. We've changed the stiffness matrix because of the new section sizes. We've also changed the seismic masses and the self-weight of the structure. So we need to re-perform the analysis to make sure that everything is still working. To do this, we're going to go up to your Analysis and Design tab in the ribbon and click on the Run Analysis icon. Again, you're going to need to save every time you perform a new analysis. Once we're done, we'll go ahead and go directly to the post-processing mode this time. Click our Done button. And then we're going to again take a look at our utilization results to see if everything's passed the code check. At this point, all of the members are passing the code check. Everything is in green. They all have an interaction ratio less than 1.0. And if I go to this Failed Members tab in the Design Results area, it's going to be empty. This completes your process for performing a trial and error approach using the code check command in STAAD Pro Connect Edition.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.